Alright guys, so we are going to now to work on a section 3.4. Section 3.4, and section 3.4 is about, you will excuse me, it's about linear and angular speed. And let's try to work on the problem number 1. Let me add some line. There we go. So problem number 1. On the problem number 1, the question is fill the blank. The measure of how fast the position of a point point P is changing is the, and what you had to write was, is the linear speed. We call also linear velocity. Linear velocity. Okay. Just to remind you, so basically what we are talking about is a point P. Let's try to graph. Okay, let's pretend we are in the center right here. Well, we're having the point P right here, and the point P is defined as a linear velocity. Just like to remind you, we are able to define the there we go. Let's try to define the radius. Okay, x-axis, y-axis. I need to be a 90-degree angle at least. Will be better. I can define the angle theta right here, when right there we have the radius r. Now if I'm looking at the problem number 2, what I can tell is that the measure of how fast the angle is changing, so the measure of how fast angle theta is changing is the angular speed. Let me write angular, or we call also angular velocity. Alright. Now let's try to jump on the problem number 7. On the problem number 7, what do we have? On the problem number 7, we are dealing with find the angular generated by P in time t, find the distance traveled by P along the circle, and find the linear speed. Okay, so number 7, we have 3 calculations. First of all, we have to calculate the angle generated by P in time. So the angle generated by P in time T. Well, they are giving you R equal 20 centimeter. They are giving us the angular speed, pi over 12 radian per second. And finally, T equal 6 seconds. So I know that omega is the angle theta divided by the time, therefore theta equal omega multiplied by t. So theta equal pi over 12 multiplied by 6, and I end up to have, by the way, per second, t is in second, it's the same unit, which is very important, and I end up to have theta equal pi divided by 2, because I can simplify by 6, both sides, divided by 6, and so I will have pi over 2. For B, the question is to find the distance traveled. Find the distance traveled by P along the circle. Along the circle. I know that the distance is the length of the arc. The distance S is equal to R theta. Theta equal pi over 2, and R equal 20 centimeter. Therefore, S is going to be equal 20 multiplied by pi over 2. We end up to have 10 pi centimeters. Finally, the third calculation is about find the linear speed. The linear speed. Okay, so if I want to find the linear speed, what I'm going to have? Well, I know that the linear speed is V equal R multiplied by omega. Omega equal, we said, pi over 12, and R is equal to 20. So the linear speed is going to be equal to 20 multiplied by pi over 12. Obviously, I can divide by 3, by 5. If I divide by 4, I end up to have a 5 right here, and I end up to have a 3 right here. So the answer is going to be 5 pi divided by 3 for C. And obviously, the unit is going to be centimeter per second. Alright, problem number 11. On the problem number 11, using the formula omega equal theta divided by t, find the value of the missing variable. So in number 11, they are giving you omega equal 2 pi over 3 radian, and it's going to be per second. And they are giving you t equal 3 seconds. So the missing variable is theta. To have theta, I need to multiply by t both sides. So it's going to be multiplied by t. So theta equal 2 pi over 3 multiplied by 3, which is 2 pi radian. So theta equal 2 pi radian for number 11. Now, if I want to do problem number 18, they are giving you theta equal 5.225 radian. and they are giving you t equal 2.515 second. Okay, so number 18. The answer is to find omega, which is theta divided by t. Applying this, we end up to have 5225 divided by 2.515. And end up to have a value of omega for number 18, 2.078 radiant per second. Okay, now problem number 22. As you can see, all of these problems are just the use of the formula, so you must be able to do this one very quickly, paying attention to the unit. V equal R multiplied by omega. So when they are giving you R equal 12 meter and omega equal 2 pi over 3 radiant per second, well, obviously, V is going to be 12 multiplied by 2 pi over 3. Number 22. Oh, I did 21. Oh, I did a 21. It's not 22. So let me do number 21 first. And so I end up to have, at the end of the day, 24 pi divided by 3, which corresponds to 8 pi meter per second. '22 is the same idea. So I'm going to do the problem number 25, which is exactly the same thing. Number 25, the question is, you have V equal R multiplied by omega. R is going to be equal to V over omega, because I need to divide by omega both sides of my equation number 1 right here. Now I know that V, number 25, V equal 18 foot per I know V equal 18 foot per second, and I know that omega equal, number 25, omega equal 3 pi over 2 radian per second. So R is going to be equal to 18 divided by 3 pi over 2, which corresponds to 18 multiplied by 2 over 3 pi, 36 over 3 pi, 36 divided by 3 is 12, so I end up to have a radius equal to 12 over pi for problem number 25, and obviously meter because we're talking about the radius.